loud noise. Okay, I think it'll be fine. All right, more review. Okay, so we're going to take a look at 1.2. Again, this is all from anything from Algebra 1 through Pre-Calc. Hopefully we remember everything. Get my fingers crossed. What'd you say? You say you forget everything? Don't say that. Don't say that. Okay, functions. How do we know if it's a function? Vertical line test is a great way. So, listen, in calculus, there's not a lot of questions like, oh, is the following a function? It's just generally we work with functions. Occasionally you might have a circle or something like that, but most of what we encounter has function, or we write in function notation, which means like f of x, right? So here we have two pictures. One of them is a function and one of them's not. So here we have a bunch of different things going to the same. And here we have the same thing in the domain going to two different things in the range. Think of this in terms of like coordinates, like x and y coordinates. Remember? It's been a while. Okay, which one do you guess? First one? Is the first one a function?
No, the second.
Yeah.
The first one. I think the second one.
I don't think
that's
that's
a
function.
Are we confused?
Yes. Will not work.
Clearly.
The
first one?
The first one.
It's the first one.
So think of these as different, these are different x values. Can different x values go to the same y value? No.
Oh, well, that's the second one.
Oh, no.
Or can they not? What,
No.
oh my goodness. Can they, I feel like we're, here we're, okay. It's day 2.
Different x values can be the same value.
Okay, let's say you have 2, 4, and 2, 2.
Vertical line test. No.
No, that doesn't work. Okay, so this has the same x with different y. So that's a no-no. Right, no, that doesn't work. Now, could you have, let's say, negative 2, 4?
Yes.
So you can have, yes, you can have different x with the same y value. Now, think of that in terms of my little clouds here. Which one is a function?
The first one.
So this one has different x value going to the same y value. Is that allowed?
Yeah.
Yes.
Yeah.
Woo! Okay, all right. So this one is a function. All right, yeah. Let's just get through this right here. Okay, let's just move on because we're never going to see these cloud things again.
Where do you find puzzles?
All right, inequality versus interval notation. You just need to know both. You should have been working with both the last couple of years. I usually like interval notation. Unless I specify, you can use either one. Okay. Sometimes I'll say write in interval notation. So, okay, block it out, Okay. All right, now we get to the part where we're like, oh no, I was fine up until this point. Now we have to graph, and we have to.
No, we already hit that point.
Okay. If you have a graphing calculator, I'm okay with you using your calculator to graph some of these if we forgot. I will remind you, we're going to have lots of review with graphing. Let's start with the first one. Now, there are some non-calculator parts and some calculator. Now, I can rearrange this to write negative x squared plus 2. So maybe that's a little bit easier for you to visualize. Now, you'll notice I have in bold, it says sketch. I don't need tons of points. This is just give me the vertex, so I go up to. I don't need to see any more points. You guys have already been tested on this in Algebra 2 and Pre-Calc. Just a quick sketch. There are places where you want to have a real accurate graph. This one I'm not so concerned about because really all I care about is I want to know the domain and the range. Okay, and then a quick sketch so I at least have an idea of what the graph looks like. So vertex, and then it's upside down, right? Now, domain. So think of domain as what we can plug in, which are, in this case, all reals. Yeah. So you can use the fancy R, or you can just write negative infinity to infinity. Either way is fine. How about range? So, okay. So what I like to do with range is I think from bottom to where the graph stops. So it goes to negative infinity. So from negative infinity to 2, and I'm going to put a bracket because it actually includes 2, right? That's a filled in circle. It's not like an open circle. There's no asymptote there, nothing. Okay, questions on that one? Yeah, okay, you can also graph, what I like to do is graph it. With domain, you can also work left to right. So see how it points down, but it's also pointing to the left, to negative infinity, and then to the right, to positive infinity. So you could do left to right for domain and bottom to top for range. Good? All right. Negative 1 over x. If you forgot what this looks like, no worries. It has a vertical asymptote at 0, a horizontal. We're going to review this more in chapter 2 also. And what does the graph look like? Well, 1 over x goes here and here. So negative 1 over x is just going to go where? It's just the opposite. Like this and this. I know that's a really rough sketch. Again, I'm just concerned about sketching it so I can come up with a domain and range. So domain, I can plug in anything but 0. So I'm going to write negative infinity to 0 and then 0 to infinity. Okay with that? And range, same exact thing because of the asymptote. It doesn't matter. It doesn't matter. I'm not going to be picky about whether you put it on. Because, again, I'm more concerned about the domain and range. There's not a lot of graphing in calculus. Most of the graphs will be provided for you, and then you have to do the work, figure out domain or range, or do the calculus with them. Okay? But you do need to be able to recognize graphs. So that's why we'll have time to review some of these. Some of these might be, D is usually a new one, letter D. Square roots, though, we should remember. So think about the half graph. It's the half parabola. So this is going to start at -4 and then up 3, right? Do you remember that? So it has a horizontal shift. So whatever's in the square root, right? It's like the opposite. So if it's +4, we move it to the left 4. Anything out of the square root is going to be a vertical shift. So it goes up 3. And this is positive. So again, it's like a half parabola, rough sketch, just to know domain and range. Now, domain. Okay, so the question is do we include -4?
Yeah.
Yes, it is. Just remember, anything square root has to be greater than or equal to 0. So that's why we know it has to have the bracket. And then the range usually has to do with just the vertical shift. So it's been moved up to 3 and it goes to infinity. And it also includes 3, same reason. It's colored in. We're good. Okay, the next one is going to show up a lot this year, and you may not recognize it. You may, usually it's a new one. This is a semicircle. Okay? So anything that has like an r squared minus an x squared is a semicircle. Now, how do I know it's a semicircle? Well, true. I have taught this before, many times. So imagine if we wanted to come up with the graph for this. Let's say I want to get rid of the square root. What would I do? Square both sides. Oh no, my pen's not working so well. So square both sides, what do we get? We get y squared equals 9 minus x squared. Okay, let's see if that does it. So I get y squared equals 9 minus x squared, add the x squared. What does x squared plus y squared look like? It's a circle. You recognize x squared plus y squared is a circle. What's the radius? 3. Okay, now, it's not, we don't want to graph the whole circle. This is half a circle. Remember when you have a square root and you square both sides, you get something called extraneous solutions? This is one of those areas. This is a positive square root, so we want just the top part of the circle. So the way I do this is I just go to 3. Oops, I kind of went above my point, but can you picture that? So from -3 to 3, and just make, now if there was a negative sign out in front, then it would be the bottom half of the semicircle. That's the extent of semicircles. So if I gave you, let's say, square, so if I gave you negative square root of 9 minus x squared, it would just be the bottom part. Okay. What if it was 16 minus x squared in the radical?
4.
Then it would have a radius of 4.
What if it's 9 plus x?
Then it's not that graph at all. I would never give, it wouldn't be a semicircle.
Wouldn't that just be like conversation?
It would look more,
Yeah, wouldn't
it would look more like an absolute value type thing.
It would look exactly like this.
What's it look like?
It's very different.
Okay. Oh, we didn't do domain and range. What's domain and range here?
-3 to 3.
Good. And range with brackets.
0 to 3.
Good. Again, you could do the domain algebraically, but in calculus, we don't waste time unless all that stuff that you did in algebra 2 and pre-calc. Okay. X to the 2/3. So this is also a new one, but let me just rewrite it. So this is a cube root of x squared. I'm going to show you what it looks like. We're going to learn more about these. It actually, oh, that looks messy. Okay. It looks like two square roots, one going to the right, one going to
The Olympic swimmer when he's in the, or the
The Olympic
The swimmers do this also, but oh, it's like click the landing.
Wait, so how did you come up with that?
Okay, this is a particular graph which we're going to learn about later. It actually has a name. This is called a cusp. So think of this almost like the top part of a heart. It's a cusp. So it comes together. So it comes together at a point. Okay. Now the domain. I can plug anything in here. It's fine because I'm taking the cube root. So I get -infinity to infinity. Notice it goes here, right, from left to right, -infinity to infinity. However, the range, because we're squaring something and then taking the cube root, you're never going to get a negative number. So we're always going to get anything from 0 to infinity. Okay, next one is a cube root. So this is like the S shape, like cube root of x. But it's moved over to the right one, so it looks like this. Again, we'll practice more of these. Again, I'm letting you use your calculators for now, and you can graph them. Now, domain, right, you could plug anything in, any odd roots, all reals.
Isn't that also -infinity?
And range is the same, right? You can get anything -infinity to infinity. Okay. We got 2 more of these, and then we'll move on to even odd functions. X to the 3rd, this one should be familiar to you. It's like like this. Okay. And so we have domain is,
Negative to positive.
and the range,
-infinity, positive.
same.
Wow.
Okay. All right, last one is, you might have to graph this on your calculator, 1 over x squared minus 4. So first thing, whenever you have rational functions and you're thinking about your domain, sometimes it's helpful to factor if you can. If you can cancel, that's something called a removable discontinuity I know you learned about. We're going to learn more. These are vertical. There's a vertical.
I was going to say isotope, and I was like,
with an A. Yeah. So you have a vertical asymptote at -2 and a vertical asymptote at +2. You also have a horizontal. Again, chapter 2, we're going to review all this, which is why I'm letting you use your calculators for this part now. And what does, so domain I can tell just based on the denominator. I can see I'm going to exclude -2 and 2. Now, what about the range? What does the graph look like? Anybody else? Yeah, did you graph it? And what's it look like? It looks like
This, and then you upside down.
in the middle. And then, so it looks like this here and also one on here.
Yeah.
There you go. So -infinity to 0.
What is the union again?
Oh, union just means it's like continued on. You can separate it with a comma or the U. Either one is fine. We just don't usually put the word and. And implies something called intersection, which is an upside down U.
Like the graph.
So we don't want to, either a U or a comma is fine to separate. All right. I know. How much more do we? I think we're almost. Oh, wow. We do have a lot. Okay. Oh, but you know what? A lot of it is just me typing up stuff that you'll probably never read. So, if I'm being honest.
Tell like it is.
Well, no, because sometimes I put in so much information, I'm like, oh yeah, that's just some words. We get to skip over that. It's more like the examples that are the important parts, right? Although even in odd functions, we should know. Yeah, how do you know if it's even or odd? Like, okay, so x squared, here's my quick sketch. So what do we know about even? It's symmetric about the y-axis. Also, if I substitute in -x, so what happens when I square a negative?
It becomes positive.
Becomes positive, so I end up with the original. So when I plug in -x and I get back what I started with, this is even. No, but I can throw in a therefore. My 3 dots, remember that?
If you plug it in negative, you get the same as the original.
Yeah. So when you plug in a negative and you get back the original, it's even. Oh. So it's an abbreviation for therefore.
Oh, I remember this. And
So
last
if-
time we did with T and H.
Sure.
I like abbreviations whenever possible, so therefore.
What's your sign?
All right, odd. Odd, here's an example, x cubed. So if I were to plug in -x, so now here's an example where if I plug in -x and I take that to the 3rd power, I get the opposite of what I started with. Right? I got the opposite of f of x. So therefore this one is odd. So odd functions are symmetric about the origin. So for example, if I have a point, like this one, I know my graph is off, but 2, 8, this one has the point -2, -8. Like the x and the y coordinates are just opposites of each other. Now, there's a quick way. So here, what did I say? We don't waste time in calculus. If there's a shortcut, we want to use it. So there's a quick way to tell if it's an even or an odd function. So if the degree of every term is even, then it's an even function. So here's an example. We got a 6th power, a squared, and then notice there's a constant at the end. Constants have a 0 power. Zero's counted as an even number. So notice it's an even. So that polynomial is even. So this one right here is an even function. Here we go. Next one. If every term is odd, then you have an odd function. So to the 5th power, and that's just to the 1st power. So this is odd and this is odd. So that means this is an odd function. Now, if I give you another combination, let's say if I had x to the 5th plus x to the 4th minus 3. This is neither. Okay? So you either, this is, notice I said this is for a polynomial. So if I give you a really long polynomial, all you have to do is look at the exponents. If you have all odd exponents, then you're good to go. It's odd. If it's all even exponents, it's an even function. And if you have a mixture of the two, it's neither one. Now, we don't always have a nice polynomial function. Sometimes we have a rational function. So if you have an even function over an even, right? So if the degree of every term is even in the top and every term is even in the bottom, then you get even. Also, if you have every term and the top is odd over odd, you also get even. Okay? And if you have even over odd, you get odd. Odd over even is odd. Any other combination will be neither. Are we kind of, now, let's say you don't like this quick way because it's too much to remember. You can always plug in negative x. All right, and if you have your calculator handy, you could see if it has symmetry. Like, look at C. C has a square root in it, so if we're not sure, you could still plug in negative x. But if you have a polynomial, use the shortcut. So how about A? So that is an odd and an odd exponent, so this is odd. How about the next one, B? Right, because we have a combination. Neither, neither. Okay, I won't start it. Okay, moving on. What do you think C is?
Even.
What do you think? Even? Andrew says even? It is. Okay, this is not a polynomial, but if you want, just think about plugging in negative x, and because you're squaring it, I get back the original, so I know this is even. Okay. And what about the next one? Even? So yeah, this is remember, constants are even because this is x to the 0. So we have even here, even here, even over even, even. Yep. Okay, we got piecewise functions and compositions. We'll see. I think we have time. Oh, don't give me that look. Not yet. Oh, so absolute value functions can be expressed as a piecewise, right? What's like this? What's the domain for an absolute value? What could you plug in? What can you plug into x? All reals, anything. And how about the range? From what to what? 0 to infinity. Do we include the 0?
Yes, we do.
Yes or no? Yes? Yes. We don't seem too confident about that one. But yes, it is colored in. Okay, graphing piecewise functions. How do we graph piecewise functions?
With our calculators.
Okay. Okay. I'm not sure. Well, let's look at the first part.
Oh, it's 3 up till 0.
It's 3 up until we get to 0.
Not
When it says 3, it's really referring to a horizontal line. So when we get to 0, for now I'm just going to put an open circle because it just says less than. I'm just graphing the first part. Now, the second part happens to pick up right where we left off, right? because this is greater than or equal to, and if I put 0 in, that means it's a square root that starts right here. So I'm going to fill that in. Make sure you fill it in all the way so it doesn't look like an open circle anymore. Again, I'm just going to sketch. This is an absolute value. I know that you guys can find lots of points if you want. We're past that.
Wait, I thought it was straight. Like the-
Wait, no, this was an absolute value. This is just a different piecewise function. This one is a square root.
Okie dokie.
Are we okay on that one? Oh, and then we have 3 parts. Oh, and do you know how to graph these on your calculators to check?
Can't you just put them each
You-
into a different?
Yeah, but you have to put, so when you put it on your calculator, you have to put parentheses with your, actually I'll do B on the calculator because this one's harder. Let's do B and then I'll show you how to do it on the calculator to check. So x is less than 0 is going to be x squared. So I'm going to put, that's that part. Now from 0 to 2, it's going to look like x to the third. So actually, for the second part, I'm going to actually go back and color that in. And it goes up to 2, 8. So that's my x to the third part of the graph, right? You know, x to the third. Yeah. And because I know it starts at 0, what I like to do is I think about plugging in points. So what points would you, here I would think of a table. I don't actually write it out. If you want to, that's fine. So starting at 0, I get 0 to the third, so that's 0. Maybe plug in 1. Okay, I missed the 1, but pretend it went through 1, 1. And then it ends up at 2. 2 to the third is 8. And then the last one is negative x plus 10, but we only want to start it at 2. Well, if it was negative x plus 10, it would start here. It'll go down 1 to the right, 1 down. So it just basically leaves off where we stopped the last one. Okay, now, to see if we got the correct. Okay, so what I need to do, I'm going to put each part, so I'm going to put x squared in parentheses. And then I'm going to put x, and then I want to put a less than sign. So I'm going to press second and then math. You see where it says test above the math button? So second, math. You get your inequality symbols. So I want less than, so that's 5, 0. Okay, next one is x to the third. Now, this one's tricky. It actually has 2 parts, and we can't just type it in the way when it's a compound inequality. What we have to do is we have to say x is greater than or equal to 0, and x is less than or equal to 2. You have to like state them separate. Well, of course it would, and there's a good reason why your teacher didn't show you. Because you probably had your calculator allowed on your test, or did you have it allowed on these parts probably? And your teachers know these things. I know. Don't you hate? You're going to learn a lot of shortcuts and other things this year, and you're like, why did my teacher not tell me? And then the last part is negative x plus 10. And then x less than 2. Of course, I think it takes longer to actually check than do it yourself. Now, my calculator, and I don't know, those of you that have like the LED, it shows like this random line. You can ignore the line, just look at the actual graph. So it goes up here, here, and then here comes my line. Oh wait, did I not put it in parentheses? Oh, I might have used the wrong symbol. Hold on. Oh, I used less than. I meant to use greater than. Sorry. I think we're going to have to finish there. So I just need to change this. So the very last part, we had this page. You have to write a piecewise function, and then these are compositions. You should be able to do the homework, but I'll make sure I finish these for your